This week we're going to be going over some TypeScript and just learning the basics, getting a grasp on that because TypeScript is the language that we use to build everything at Hack for Impact. So you may have heard of JavaScript before. Show of hands, JavaScript. Nice. Okay. So TypeScript is like JavaScript, but better. Okay. Don't use JavaScript, use TypeScript. All right. Yeah, so today we're going to take a look at some of those basics, get you a little bit more familiar with it. So let's go ahead and jump right in. If you've read the onboarding, you'll know that we have you install a program called Node. So this is how we actually run our TypeScript code, similarly to how the Java program is how you run your Java code, right? In order to get started writing some TypeScript, we'll actually need to create a new TypeScript project, which I'm going to go ahead and do now. So I'm going to come into my VS Code. I'm actually going to open the folder where I want my TypeScript project to be. This is in school, orgs, Hack for Impact, WDW2, TypeScript basics. And then, oh, awesome. My thing is not there. Okay, sure. This works. Man, this is annoying. Oh, look at that. So I can go ahead and remove that. So now we are in, excuse me, all this stuff. So now we're in this folder in VS Code. What I can do is I can run these two commands and they're going to get everything set up for doing some TypeScript. So first I'll run npm init. And that's going to just take me through a bunch of stuff. I'm just going to hit enter, 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 enter. Yep. There we go. And then I will run npm install dash dash save dev TypeScript. And you can follow along. Don't worry about it though. We will have like an article that you can read if you want to like go back and do a lot of this stuff. And we'll just give you these commands. So that's how we do that. So now we actually have our project ready for TypeScript. So what I can go ahead and do is in VS Code, I can come over here to the left-hand side where all my files are, and I can right click and hit new file. Wait, did I do that? And then I'm going to just name this anything.ts. And .ts is how we specify that we're writing TypeScript, like how .java means we're writing Java, right? So I'm going to just call this lesson.ts. And then in classic programmer fashion, we're going to go ahead and just write a simple hello world in here. So I'll do console.log hello world. Okay, and then I'll save that. And you'll notice that we use this weird console log thing. This is how we actually print stuff out in TypeScript. So what I'm doing here is I'm just pulling up a Java example of the same exact code that will output the exact same thing. So you can see the difference between Java and TypeScript. So whereas in Java, to print something out, you would do system.out.println hello world. In TypeScript, you say console.log hello world. Okay? Any questions about any of that? Good so far? Sweet. So I'll go ahead and run this, and then I'm going to just copy this command that I can use to run my TypeScript. Hit enter, and you'll see at the bottom here, we get our hello world. So this actually worked. We have this hello world text printed out, and we're good to go writing some TypeScript. So let's go ahead and get started with the basics. First, obviously, in any programming language, you have variables, right? So in TypeScript, there are two ways to declare a variable that we're going to talk about. The first one is called is using the let keyword. So I say let and then my variable name. And then I set it equal to something. So we're just going to say this is equal to smart. Okay. And then we can go ahead and console log that out. And you'll see here, if I run my code again, I just press the up arrow to do my most recent command. When we printed out that variable, it printed out smart. So let is a lot like var in Java. When you do let, your variable can be changed. So if I come in here and now change student to say genius, because this is after you guys have taken our web dev workshops and been on the learning based project, I can change that to genius. And if I actually save the file and run it, you'll see that originally it was smart the first time we printed it out. Then after we changed it and printed it out, it was genius. So that's the first way to define a variable. The next way is using a keyword called const. So const means that you're defining a constant, okay? Let me scroll down a little bit here. Wait, okay, yeah. So const means you're defining a constant, right? So I can say const student equals, and this, let's just say having fun. And then I can go ahead and try and reassign this. But if I do student equals bored, you're going to see it gives me this red squiggly. It's when I hover over it, it's going to say, hey, you can't do that. Cannot assign to student because it is a constant. So you use const when you have some sort of data that you know won't be changing. You don't want to reassign it. That's when you'll use const. For most cases, you'll want to use const, but if you need to actually do a reassignment, that's when you'll reach for let. Any questions about let versus const? Yeah. That is a great question. So in Java, I'm sure you all know you have to say like string student equals string or whatever. TypeScript is actually super smart. So it actually knows if I change this to let here, it actually knows that because I'm assigning this to a string, the type of this variable is a string. So you can see it's just automatically doing that. I could specify it by doing a colon after the name of the variable and then the type I want it to have. But you don't need to because it's really good at inferring that. Any other questions? Good question, by the way. Yeah.
So there's no like semicolons at the end of the lines, like
Oh, you can. It's weird. JavaScript or TypeScript used to make you do that. Now they're like, you can if you want. You don't have to. The important thing about that though is that you're just consistent. You either use semicolons everywhere or you don't, right? It's not like it's not going to make a difference, but you just want to be consistent in the choice you make.
So let's say you had student without specifying that it's a string, like if you deleted that portion. So what would happen if you tried to set student equal to a number?
Let's go ahead and try it. Oh, it says, hey, you're trying to make student a number, but it's a string. Type number is not assignable to type string, right? So just like in Java, you can't assign a number to a string variable. Same thing in TypeScript. All right, awesome. Any other questions? Cool. So while we're talking about strings, we've used strings a couple of times. Let's go ahead and like really talk about those. There are actually 3 ways you can declare a string in TypeScript. And the first 2 are either using single quotes like I have here, or you can use double quotes. And I want to note that there is no difference here. There's literally no difference. It's always a string regardless. They just let you do either way. And which one you choose, again, like the semicolon thing is personal preference. But again, just make sure that you're consistent in that choice. You don't want to have like let student equals having fun and then with the double quotes and then student equals bored with the single quotes and then no semicolon. You want to be consistent everywhere. There's also another cool way that we can define strings. And to show you that, first I'll define 2 variables. I'll call the first one person, and we'll say this one is Andy Samberg. And then we'll say const job title. Andy Samberg is a comedian, so he's a comedian. The third way that we can define a string is using backticks. So I'll define a new variable and say const true fact. Oh, I forgot to turn off Copilot. Spoilers, don't look. Okay. We can use backticks. So backticks are on the same key as the tilde right next to your 1. You just don't hit shift and press the key next to the left of the 1, and that'll give you backticks. Backticks are super useful when you want to insert variables into your strings. Okay, so I can actually put variables in here and it will like put whatever the value of that variable is into this string. And you can do that by doing $ and then curly braces and then the variable name. So I'm going to put person is the funniest job title in the world. Okay, and then that's actually going to take this person variable, put it in the string, this job title variable, put it in the string, and I can go ahead and console.log that, true fact. And we can see that in action. If I press the up arrow and run my code again, you'll see it prints out, Andy Samberg is the funniest comedian in the world. Any questions about backticks or strings or anything like that? All right, sweet. Let's go ahead and move on. We're gonna now talk about array. Excuse me, sorry, y'all. We're gonna go ahead and talk about arrays. So just like there are arrays in Java, there are arrays in TypeScript, and you can actually create a new array using square brackets. So let's go ahead and make a new array here. Const goals equals, and then whereas in Java, you'll use curly braces to define an array, here in TypeScript, you just use square brackets. And then this is, I'll put 2 of my goals in here, become the best web dev on earth. And I also want to have fun, right? And now we have declared an array. I can go ahead and print this out just like anything else. And you'll see my array is printed. The first element, become the best web dev on earth. The second element, have fun. And then again, just like in Java, you can access specific elements of an array using the name of the array, then square brackets, and then whichever element you want to specify. So this should look very familiar. This is just like Java. And then again, just like Java, arrays are 0 indexed. So the first element is actually going to be at index 0. So I can go ahead and console log goals 0. And you'll see we get back become the best web dev on earth. All right. And then the last thing we're going to look at with arrays for now is adding to an array. Well, let's keep the goals. So I don't remember exactly how it's done in Java, but in Java, you can like append to an array, add a new element to the end of it. You can do the same thing in TypeScript with goals.push, and then whatever you want to push in this array. So I actually want stay hydrated to be another one of my goals. And I can go ahead, I'll print that out at both stages. So I'll print it out before the push and after the push. And you'll see when I run that, we first have become the best web dev on earth and have fun. Then after we push stay hydrated, we have become the best web dev on earth, have fun, and stay hydrated. Okay. So that's arrays in JavaScript, very similar to Java. The only difference is how you define them. Any questions about any of the array stuff?
Arrays are resizable,
Yes.
like array list.
Yeah. Oh, yeah, exactly.
Like vectors too.
Yep. Vectors in C++ or array lists in Java. Good question. Awesome. So now we're going to go ahead and move on to another concept in TypeScript called objects. So you know how in Java you have classes where you can assign multiple pieces of data to a single variable? You can have like a person class, and that person might have a name, an age, and like a greatest flaw. You can do the same thing in TypeScript. So let's go ahead and create an object. We'll first make our variable const teacher. And then to define an object, we use curly braces. And then inside of the object, we have a property name colon the property value, right? So in this case, we'll have a property called name, and the name of the teacher is Xavier. We'll have a property called age. I'm 22. And then we'll have a property called greatest flaw. And for me, unfortunately, it's being too handsome. Okay. So I can actually go ahead and print that out now. And we'll see when we print that out, we get back the object. We see that we have the, I'm not going to point, we have the name property with Xavier as the value, the age property with 22 as the value, and then the greatest flaw property as being too handsome as the value. So this is really useful for when you have like data that kind of goes together. You want to keep it in a single variable. You can put it all in an object. Okay. So something related to objects in TypeScript is this concept called interfaces. So an interface lets us specify the exact properties that we want on an object, right? So for example, we can create an interface for a UTK student. So let's go ahead and do that. UTK student. Now, inside of this interface, we define what the property name should be. So a UTK student will have a name, and then what type that property should be. So the name is going to be a string, right? Because it's just any old string. The age, we can also specify an age on a UTK student, or sorry, not an age, a GPA on a UTK student, and a GPA is, shout it out. Yes, integer, double. In JavaScript or in TypeScript, those are actually the same thing. So they both fall under one type, just called number. Okay. And then on top of that, so those are the two of the three primitive types. The third one is a Boolean. So that's just true or false. So you have string, number, Boolean. So a GPA is a number, and then finally a major. And the major is, let's say a UTK student can be undeclared, right? A lot of freshmen, when they come in, they don't actually have a major. So we don't want major to be on every UTK student. We want it to be optional. We want some UTK students to have them and some not to, right? So we can specify that by after we write down the name of the property, we do a question mark and then do like we would normally with the colon and then the type. So this is saying that a UTK student has to have a name, they have to have a GPA, and they can have a major, but they don't have to, right? Okay. So now we can actually combine this concept of interfaces with this concept of objects to actually create a new UTK student. So let's go ahead and create me. So Xavier, and here I am going to specify the type. I'm going to say, hey, Xavier is going to be a UTK student. Okay. So I just do that colon, what the type is, UTK student. And then just like normal, I hit the equals and open curly braces to define our object. And now it's going to start yelling at me because I've said it's a UTK student, but I'm actually missing you'll see type empty object is missing the following properties from UTK student. It needs me to have a name and a GPA. Okay. I'm a freshman just coming in. I haven't declared or I haven't said that I'm doing CS yet. So I actually have a 4.0 GPA. And now it's totally fine. It's all good. We are looking good. It's not yelling at me. But any questions about that? Okay, sweet. So now, this is great, but I'm going to want to update this as I go through school. I'm not going to keep the same GPA. I might declare a major. And so I'll need to update these specific properties on my object. And you can do that in two ways with TypeScript. So the first one that we'll talk about is called dot notation. So I can say Xavier, which is my variable name for this object, dot, and then the property name that I want to access or update. So I want to actually update my major because I just, after my first semester, I've gone ahead and declared that I'm going to be a computer. Oh, go ahead.
So put a comma after Xavier,
Yes.
but you didn't do it first main interface.
Okay, yeah, that's a really good point. So with the object, you can think of the object almost as like similar to an array where you're defining the first thing with a name with a property name, then the second thing in its property name. Whereas with the interface, these aren't necessarily in any order. What's a good way to explain why you need a comma there? I'm struggling with that.
Just continue.
Yeah, so when you define an interface, yeah, I won't go into it. When you define an interface, you don't need the commas. That's like line by line, so that's good. You can put semicolons there if you're doing the semicolon thing, but you don't put commas. Then when you define an object, you actually do put commas. I don't know a good explanation of why, but yeah. Yes.
You're referencing, or like when you're creating a new object, Xavier.
Yeah.
You have to like specify, like name, colon, Xavier. It doesn't have, like, you can't rename a string. It has to be like, it has to match the name of the interface. Like the naming convention of interface where you have name and GPA, so you can't put in like a new name for a string and a new integer. name.
Well, so are you saying like I can't down here like modify this? Like I can't say,
Change your, visualizing like name, could name be a different, variable name, or does it have to?
oh, yes. So the interface is saying you have to have these properties, right? So you have to have a property called name, and that has to be a string. You have to have one called GPA, that has to be a number. So I couldn't do something like capital N name because one, we only have this lowercase n name and we don't have a capital N name.
I'm just wondering, because if you, I didn't know if it's like name specific, obviously it's not, like, I didn't know if you were requiring some sort of string, some sort of string.
Right.
Specific case.
Yeah, that's a really good question. And that's kind of where the usefulness of interfaces come in, right? Because like now, if I know that something is going to be a UTK student, I know it's going to have something called name on it. And I know it's going to have something called GPA on it, right? Any other questions? Great question. Yeah. Yeah. Right. Yeah. That's a definition, and an interface is like a definition. Yeah, definitely. All right. Any other questions? Yes. So with TypeScript, it actually runs through your code line by line and executes it, right? So you remember, if you remember when we did the console log example, that wasn't in a main function or anything. I just ran that file and it went line by line and executed the code. Does that make sense? Right. Right. Any other questions? Awesome. Great question so far. Um, So yeah, I'm gonna just restart here. So now we need to update it, right? I declared my major, and there's two ways to do that. The first is called dot notation. So I'll say Xavier, which is my variable name, dot, and then the property name that I want to access or update. So in this case, I'm updating the major, and you'll see it gives me some nice autocomplete. So I can just hit enter on that. And then I can try and set it to computer science, and that works out just great. Again, since this is TypeScript and since we specified that major has to be a string, if I tried something like my major is 23, it's going to yell at me, right? Because I'm trying to assign a number to a string. So let's go ahead and undo that. And so I can actually now just go ahead and console log Xavier before I updated major and after I updated major. And if I go ahead and run this code, you'll see that the first time I printed out, we have name Xavier GPA 4. Then the second time I printed out, we have name Xavier GPA 4 major computer science. Okay? Make sense? Cool. So now I've declared myself as a computer science computer science student, and I took 101, and that messed me up. I didn't do good. So that actually affected my GPA, so I need to update that. And to do this, we're going to look at the second way to update or access properties on an object, and that is called bracket notation. So this is something you might have seen before with a hash map in Java or C++, but what I'll do is I'll say my variable name, Xavier, brackets, and then inside here, I'll put a string that specifies one of these names, one of these property names, right? So here I want to update my GPA, and I'm going to set that to 2.7. Okay. So both of these ways are valid for updating properties and getting properties on an object. Again, it's personal preference. You want to try and be consistent with this as well. And so I will go ahead and just console log this at the end.
I will say using the dot notation is probably generally a little safer because if you have a typo, it'll catch it, whereas it won't with the bracket notation. It will.
Yeah, it'll catch it. Oh, nope, I was wrong. Yep, Andrew's right. Listen to Andrew. Yeah, so what he's saying is like, you see here, wait, I forget I'm recording. You see here, we're able to actually set this GP field when this isn't actually defined on our interface. So you do definitely mostly want to hit the dot notation, because if I tried that here, it's gonna be like, I don't know what you're talking about, dude. try again. You know what I mean? But yeah, as you can see here, we have successfully updated the GPA and the major.
Are some instances when you still would want to use bracket notation, so we want to cover it, but yeah, generally dot notation if you can.
Yeah. Any questions about that before we move on?
So can you do like Xavier dot GPA to rechange it, or does it have to be bracket?
Yes, so you can do either one, right? I just wanted to show you both, but I could totally do Xavier dot GPA equals 2 dot whatever. And I could just as easily also do Xavier bracket major equals whatever. You know what I mean? So they're interchangeable. The dot notation is safer. Any other questions? Good question. That's a great question. So you can do it with the brackets, it looks like. So I could do 22, and if I print that out, it actually works. You generally don't want to do this, right? Because we've defined what our interface looks like. So we want to stick to that. So again, if I do Xavier dot age equals 22, that's going to yell at me and say, hey, this isn't defined. Don't do that. So that's why you want to use the dot notation. It'll just prevent you from like shooting yourself in the foot. You know what I mean? Yeah, good question. Any other questions? Awesome. So that's objects and interfaces. Now we're going to go ahead and move on to functions in TypeScript. So these are again similar to Java, but a little bit different syntactically. So in TypeScript, when you want to define a function, you use the function keyword. So I say function, and then I say what I want my function to be named. So I want this function to be named hello world. And then I do an open and close parentheses. And then I do some curly braces. And inside the curly braces, this is my function body. This is the code that's going to be run when I call this function. So here, this is a hello world function. So I'll just console log hello world. Right? And so that's how we defined our function. Now, if we just ran this code right now, it's not actually going to do anything, right? Because we've defined the function, but we actually need to call it in order for it to do something. So let's go ahead and do that now by just typing the name of the function we specified earlier and then open and close parentheses. And I can run that. And it actually does what we're expecting. The hello world, the line 5 gets called. It's like, okay, I need to run this hello world function. And so it goes up in here and it starts running this code in here, right? Pretty similar to Java. I think the big difference is that function keyword. And then again, just like in Java, TypeScript functions can also take in arguments. So let's go ahead and instead of hello world, let's make a function called print greeting. And we'll say we want to greet someone and we want an argument for who we should greet. So we'll say we want someone's name, and then here we specify the type like we do everywhere else with the colon and then the type. And then again, use those curly braces, and inside of those, this is our function body. So this time we'll do console log, and then we'll use that backtick string to say hello, and then name. Right? So does everyone see what's going on here? Sweet. And then when we call the print greeting function, print greeting, we have to pass in the name that we want to greet. So I'm going to say Andrew, and it will, if I now run this, there we go, right at the bottom. Hello, Andrew. What's up?
So like earlier, for data types on descriptions, set strings, but you have
Good question. Yes, because, if I don't define this here, then, I can pass in whatever I want. I can pass in 23. I can pass in an object if I wanted to, and so by specifying the type here, we make sure that you can only pass in a string to this function. Good question. Sweet. And then again, just like in Java, you can also return data from a function. So to do this, we're just going to modify this function a little bit. Instead of print greeting, we're going to call it get greeting. And then we will say, just like how we can say what type of variable is, we can say what type of function is going to return by saying after this whole bit with the name and then the or arguments it can take, we're going to do a colon after that and say what it should return. And immediately it's going to start yelling at me. It's going to say, hey, you're saying that you want to return a string, but you're not returning a string. So I'll say, okay, you're right. Let's go ahead and return a string instead of console logging it. And now, just like before, I can call that function with a name, and this time it'll give me back a string. So maybe I want to say const Andrew greeting equals get greeting. And then we pass in the name we want to greet, Andrew. And then now I can do whatever I want with this variable. In this case, just to show you guys, I will just print it out. All right. So yeah, there you can see, again, we now have assigned it to a variable, then printed out that variable, and it's the same thing. Yes.
Very smart. It looks at the return type of the function. It knows that function is returning a string. So it knows that Andrew greeting is also a string.
Yeah, I love it. It's great. All right. Any questions about functions? Super similar to Java. Awesome. Perfect. And I know this like colon syntax can be a little weird, especially coming from Java where you put the types before everything. Every programming language has a different way of doing that, which sucks. Okay. So we have about 25 more minutes. What we're going to do now is look at some looping mechanisms in TypeScript. So first I'm going to copy in some code that's going to help us out with this. So let's go ahead and copy that. I'll paste this in. No. What? Okay, go away. Stop. Go away. Accept. Okay. So I'll go ahead and paste this in. And let's take a quick look at it. We define an interface for a dog. A dog will have an ID, a name, and a temperament. That ID is going to be, for this array of dogs, we have a poodle, a Bernese mountain dog, and a Labrador retriever. And then we can see they're like intelligent, whatever. And then we also have a function here called print dog, and that's just going to take in a dog object. So something that looks like this. And then it's going to print out that dog's name. Okay. So this is just to help us out. We have this array of dogs here. And what we'll do first is we'll look at a for loop like you've probably seen in Java and C++. So, with that, you just do for. And then remember in Java or in TypeScript, you use let to declare a variable I equals 0. I is less than dogs.length I plus plus. All right. And then our goal here is to print out each dog. So what I will do is I'll say const dog equals dogs I, right? I want to get the dog at that index. And then I will just print that dog. And if I run that, we should get poodle, Bernese, whatever. Yep. And then Labrador retriever. Right? Looking pretty familiar. Seen this before in Java and C++, right? Yeah. So that's great, but you'll notice each time I do this, I have to specify a new variable for a dog and then access this dog at I, and like I'm not really using I for anything else. So wouldn't it be great if I could just say I actually just want to loop through each dog in this array and get the dog instance from that? And you actually can. So we'll take a look at what's called a for each loop next. I'm going to console or comment that out so we can still see it. But with a for each loop, let me look at my reference here. With a for each loop, what you do is you say for const dog of dogs. So you're saying loop through each dog in the dogs array and give me a variable for each dog called dog, right? And then in here, I can just super easily call print dog on that, and boom, we're good to go. So as you can see, instead of having to manually declare our dogs variable by getting the correct index in the array, we just get it for free. Sweet. Any questions about that? All right. So there is one other way that you can do this, and that is with a helper function on arrays called for each, right? So this is a for each loop, but there's also a for each function. A little confusing. So what I can do is I can say dogs, my array, dot for each, and then inside of here, I can pass in what I pass in here is I do inside of these parentheses, another set of open parentheses, dog equals greater than sign. And it looks weird on my computer, but if I press space, you can see it's literally just an equals and then a greater than sign. And then open curly brackets. And then in here, I can do print dog. And that's going to do the same thing as before, where if we run this, we now get each dog's name. Okay. Well, did we say we're going to go in this? You do it.
Yeah, so basically what's happening here, if I could do the touchpad.
Yeah.
Very similar to this last for each loop. This is just the for each function. For each dog, and we can see if we hover over this dog, it says it's of type dog. It knows what the data type is there, the interface that we're using. So for each dog, we'll take that and run it through whatever code is inside of these curly braces. In this case, we are printing the dog. We could also print the dog and then you dirty dog. And then we could also right after this just console log the dog's temperament. I could do that and run this code, and we can see it'll do both of those things inside of that for each function. So for each dog, it prints out the dog's name, which is this function call, and then it also prints out the dog's temperament. Any questions on that for each function, how that works? And you can do that on any array. Cool. Awesome. I think that's good.
Yeah, perfect. Cool. So that's arrays and looping in JavaScript, or in TypeScript, excuse me. There's one more thing I want to talk about, and for that, I actually have my expert help me explain this because it's very hard. If you don't know what my expert is, there you go. Let's see here. Okay. So the final function that we're going to go over is another one that you can use on arrays, and it's called the map function. So what I'm going to do here is I'm going to kind of explain what's happening. Then I'll give you an analogy for thinking about it. And then after that, we'll go over an example. Okay, because this one's a little confusing. So in JavaScript, the map function you call the map function on an array. So if you pretend we still had dogs here, I do dogs.map. And then inside of this map function, we can do some sort of operation on every single element in the array. And then based on the result of that operation, a new array will be created. So if you look at what well, I guess, yeah.
Do it with the example.
Yeah. So for a quick example on how to kind of think about this, let's use an analogy. So let's say you have a shelf of books, right? And you want to read these books, but they're all written in French. Okay. You don't know French. I don't know French. Maybe you guys do. So you can't read them. So what you do is you call up this service, and this service is specializes in translating books from French to English. Okay. And in this service, they have employees who will take your book, read it in French, and then write a new book in English. Okay. And then once the service is done, it'll give you back all of your new books in English, right? That's kind of like what's going on with the map function. Okay. If you think about your French books as the original array, okay, the English book as the new array, and the translator service as the map function, and the translators themselves as the operations you apply, that's like what the map function is doing. Okay. And that's, again, super confusing. So let's go over an example. I'll paste this in. So as you can see here, we have an array of French books, Le Cool Guy, Oui Oui, and and we want to get those translated into English, right? So what we'll do is we'll call up our translator service, which is our .map function, and then we'll have those translators translate French to English, okay? So what we're doing here is we're saying for each book that I have, I want you to translate it from French into English, and I don't want you to write that English in the French book. I want you to make a new book and give me that new book, right? So as you can see here, instead of modifying the French books, we're actually getting a new array of English books. So if I go ahead and run that, you'll see, wait, what? Oh, I didn't save it. If I go ahead and run this, you'll see that our original French books were Le Cool Guy, Oui Oui, and Oh Ho Ho Ho. And then we get back The Cool Guy, Yes Yes, and Ha Ha Ha. So these books have been translated from French into English. And you'll notice that I still have my French books. After I called this map, the French books weren't changed at all, right? We still have the French books, but we also have our new English books, right? Yes.
So translate is a function. Was it actually?
So yeah, I kind of hid the details, but I have this function that I wrote here called translate French to English. And all it's doing is it's essentially going like, hey, find a "le" and replace it with the, like, it's super basic. But like the point is that you can pass in a function that like will do something on each element in the array, and then you'll get a new array out of it with those results. Does that make sense? Any questions?
Here's a little visual. We start with our array of French books. For each of those, which is what the .map is doing, it's running all of these through the translate French to English function. Then it pops out the other side in English in a new array. So we take this, run it through the function, we have our new first element. Take this, run it through the function, we have our new second element. Same thing here, run it through, we have our new third element. Then we have our array of French books and a new array of English books.
Yeah. Awesome. Any questions about that? I know the map function is particularly very confusing. So please, if you don't understand, ask.
So it's just like a for each loop on like every element, and then just makes another array.
Yeah. So you could almost think about it as like a regular old for loop, except you're creating a new array instead of modifying the old one, right? I should have had some code that's like here's what it looks like with just a for loop to show that, but I don't. Any other questions? Is this making sense to people? You guys get this? Yes, no? Okay, let's do it. So just to really cement it, let's go ahead and look at this. So I'm going to delete my English books array and all of this stuff. Actually, I'll just delete this. And I'll say const English books is just an empty array. And so instead of using the map function, I can just do a for loop. So I'll say for French book of French books. So I'm using that for each loop, and I forgot to say let. Right? And then I can say const English book is equal to translate French to English, and then I want to pass in the French book that I want to translate. And then instead of modifying the French books one, I'm just going to push the English book in the array of French books. What's wrong with O? And this is just an array. So it actually, since this is an empty array, I need to specify that this is a string array. Right? So this is doing the exact same thing as the map function. We're looping through each item. We're creating a new book with that translate French to English function. And then we're adding that new book to our array of English books. And if I actually run this code again, you'll see that our output will be the exact same. So map is just a more concise way to do this, and it's something you'll see a lot in our projects. Does that help? If anyone was confused, anyone's still confused, please let me know. All right. Well, awesome. In that case, Yeah, I think I summarized it. Oh, yeah. So in all of our projects, we use TypeScript. You'll see a lot of this code written. It's used in all of our projects. These are just the basics. You'll pick up a lot more on your learning-based project team. But this is like a good start, and this is a lot of the stuff that you'll use every day. This is like 75, 80% of what you'll use every day. So, pretty good.